Well, my friends, I got Scott on camera today, and I got pretty thick skin, like the famous dragon skin coatings that they have and dragon skin toolings that they have at Ceratizit. But today we get to talk about something that's just been released, and we get to hear it here first. Scott, a six-flute tool focused on an industry that sometimes we don't pay as much attention to, and we should because, well, we'll let you get into that because the materials are everywhere and the industries are booming right now. And Ceratizit was clever enough to say, you know what, we need to focus on this because not a whole lot of people are. So let's talk about this tool today, Scott, and how it benefits the people watching.
So what we're doing is we're introducing our new six-flute end mill, which was engineered for the ISO-S material family. So that would mean anything from cobalt-based, iron-based, nickel-based alloys. So your Waspalloys, your titanium, your Renays, and as well as, you know, the typical titanium alloys that we run into, the 6AL4V family particularly. So very, very excited.
Firstly, let's get into why six flutes in this family of materials.
Sure. Well, probably one of the most popular flute choices out there today is the 5-flute, which in itself is very, very versatile. But what we have found that most people on their radial depth of cuts are, you know, roughly maybe 20% radial step over, sometimes even less than that. So if you're going to do that, why not add an extra flute? It's going to give you that much more extra stability. You're able to feed it a little bit faster, and your tool life goes up.
And we're, with that extra flute, as the conversation may go in some other areas, we're not gumming up the tool like we might do in an aluminum or something like that, right?
Right, absolutely. It's very, very free cutting.
So tell me some of the details about this tool for that family that we're focused on, the titaniums, the Inconels, these nickel-based things. What did you do in the profile, other than just the flutes? What did you do in the coating? What makes this tool so doggone unique?
Okay, so we actually built it from the foundation up, meaning that the substrate that we used, we made sure that the substrate is ideal for ISO-S. So it has a very, very high toughness without really sacrificing any hardness. So we're really getting the best of both worlds with the substrate. It's hard, but yet it's tough. So we kind of covered the gap on that range. The way we arrange the flutes, there's nothing symmetrical about it. It's asymmetrical, thus meaning that each tooth is on a different helix angle. And what that does, it gives you extra stability throughout the cut, and you're attacking the approach of the workpiece, cutting it at different angles, which makes it very, very free cutting and very stable within the cut.
All right, well, I'm certainly convinced in the geometry, and anything we build from the base up, we know has quality because we are in control of everything that goes into it. But why this industry? Why did you select this area of materials? Is it not being supported like Ceratizit thinks that it should be? We definitely see it everywhere. We know aerospace is booming right now, and titaniums are all over the place. Is that the idea and the mindset?
Yeah, basically we're seeing super alloys being used more and more throughout the industry. It's not only, it goes well beyond the aerospace industry, it's in oil and gas, it's in the medical industry, and it's being widely used. And today we're here at, you know, VAC Motorsports. They're using titanium on some of their parts. As the demand rises, we're prepared and have a cutter for those particular applications.
And this is brand new. I mean, we're talking, this is, this interview even, we got excited that it showed up for us, right?
This is brand new because yet it's very versatile in its range of operation in terms of machining apps. You know, we're covering the full ISO-S range. You know, again, like I said, nickel-based alloys, cobalt-based alloys, titanium alloys, but yet it's optimized within that range. So it's very super focused on what it can do in terms of performance.
Before I ask you kind of my final question of, well, now that we've excited everyone watching right now, how can I get it, right? Everyone's probably salivating, going, Scott, can I get one right now?
Right, exactly.
The last thing I want to ask is, if I buy one of these, and this is just a kind of off-the-wall theoretical idea, but I buy one of these and I knock out a job, and I've made so much money because of my reduced cycle times, my longer tool life, because this tool is focused on that area, and I'm like, well, I don't know if I have another job coming in, but I got a whole lot of steel over here. Can I use it in other areas?
Sure.
How does that work?
So you could use it in high carbon steel, you could use it in stainless steel. It's going to work very, very well. It's just not optimized like it is, you know, its intention for the ISO-S. So you're at nearly at full optimization when it comes to ISOS materials. So a big difference from like our competitors, you're going to see about a 10-15% gain over using, you know, a typical end mill that may be universally applicable for a full range of operations. This is drilled down, this is optimized, so it gives you that extra kick in not only, you know, speeds and feeds, but tool life and surface finish on the part.
On your resume, do you also have mind reader? Because I was just getting ready to ask you about, because it is so new, do you have any statistics on what's been done already? You mentioned 10 to 15%. Do you have any other facts, figures, numbers that you can throw at us to help us understand the importance of what happens when we focus our tooling as it's supposed to be used instead of just generically, gratuitously throwing something at a project?
Right. So we did our benchmark testing in Europe, and we used a lot of our competitors' tools. We went head to head, and the nearest competitor was 20% behind. Whew. So it's huge. Yeah.
That's some serious numbers.
Yeah, it's a game changer, because again, we've engineered the tool to be, you know, optimized, substrate, geometry, the micro geometries, meaning the edge prep, as well as the coating.
Well then, my final question, how can we get some? How do we find out more? How do we learn about this? And when can we have it?
Yeah. Our official launch will be July, so we're getting everybody excited. We're running content, you know, test tools today. We're running tests pretty much over the next few weeks to get this, you know, this end mill introduced to the industry. We're very, very, very excited.
And this, I imagine, will also be seen at IMTS?
Oh, absolutely.
Yes.
Yeah.
All right, everyone. So thank you all for watching. If you're in this world of super alloys, speak to my guy, Scott. Ceratizit has focused a technology to help you succeed. 20% in early testing. Imagine what you can accomplish. Imagine the money you can save, the efficiency, the cycle times. It really does matter that you pick something that works for your specific project. So reach out to Scott anytime. Thank you all for watching. Scott, you are absolutely the man, my friend.
Yeah, thank you very much.